Hey, so here we are not only going to understand how to solve this particular word problem, but we'll be understanding how to solve any word problem in general. The most important thing that we are going to learn today is the approach, how to approach a word problem. And the first and the most important thing that you should know is how to write the given data. Once you know the given data, then solving the entire word problem becomes easier. So, how do we start? We simply start by reading the question. So, let's read this question. Mahendra and Virat. So, first of all, we can see we have Mahendra and Virat in the question. So, let us have Mahendra and Virat with us. Now, Mahendra and Virat are sitting at a distance of 1 meter from each other. So, the moment we have a number, we stop over there. So, here you can see we have a distance of 1 meter. So, from that number, we are supposed to crack a given data. So, what is given to us? Distance, right? And in this chapter, we know that the distance between the two objects is denoted by small letter r. So, here the distance between them is 1 meter. So, in the given data, we'll write small r is equal to 1 meter. So, the most important thing is the symbol. You should know the symbols of each and every term or the physical quantity that you are going to use in this chapter. So, here r is equal to 1 meter. Now, we know their masses are 75 kgs and 80 kgs respectively. That means masses are given. How many objects do we have? 2. 1 and 2. So, what would their symbol be? M1 is equal to 75 kg, M2 is equal to 80 kg, right? So, we have masses M1 and M2. So, M1 is given to us, that is 75 kg, M2 is given to us, that is equal to 80 kg. Now, what is asked in the question? What is the gravitational force between them? So, what are we supposed to find? Gravitational force. You might think gravitational force, so sometimes students do make a mistake. They say that we are supposed to find the value of capital G. No, we have to focus on the word F. Gravitational force denoted by capital F. So, that is what we are supposed to find over here. So, now we are supposed to choose which formula should we use in this particular numerical. Now, let's think. What are we supposed to find? We are supposed to find the value of capital F. That means in this chapter, we have two formulae for capital F. This is how you'll think. How many formulae do we have? We have two formulae, right? So, F is equal to capital G, M1, M2 upon R square, and F is equal to MA. Let's decide which formula to use. Look at the given data. What all do we have? We have R, M1, M2. So, R, M1, M2, right? The only thing that is missing over here is capital G. But we know that we can use this formula as long as we know the value of capital G. So, first of all, we'll write this formula in the formula section. But we also know for a fact that we have memorized this value of capital G, that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So, here we have the given to find and the formula. So, we are ready with the solution, or for the solution in fact. So, now we start the solution. So, in the solution, we simply have to substitute the values in the formula that we have. What is the value of capital G? It is 6.67 into 10 raised to minus 11. Then we have M1. What is M1? It is 75 kg, you see. And M2 we know is 80 kg. Upon R square, what is the value of R given to us in the given data? 1. So, we have 1 square. So, now let's do the calculation. So, in the numerator, we have 6.67 into 10 raised to minus 11. We'll keep it as it is. Now, here we'll do 75 into 80. So, pause this video over here and multiply 75 and 80. I hope you got the answer as 6,000, right? So, upon 1 square is nothing but 1. So, anything upon 1 becomes anything. So, this remains as it is. So, now in the numerator, we have 6.67 into 6,000. So, when you multiply 6.67 and 6,000, do it. Yes. So, now when you multiply, you get the answer as 40,020, right? So, 40,020 remains as it is. Into 10 raised to minus 11 is still left. So, don't forget that. So, now we get the answer as 40,020 into 10 raised to minus 11. But this is not how we write the final answer. We have to write the final answer in standard form. So this is not the standard form, because when we write an answer in standard form, we should know that this number has to be between 1 and 10. And what is standard form? Whenever we have an answer in the form of this, when we have a power over here. So this number has to be between 1 and 10. Is this number between 1 and 10? No. That means 4.0020 would be or should be the ideal answer. So if I write 4.002, I cannot write into 10 raised to minus 11. I cannot simply change the number, right? So what we have done is, initially the decimal was here. So we shifted the decimal beside 4. So how many places did we shift? Let's see. 1, 2, 3 and 4 places, right? So we have shifted the decimal by 4 places. To the left or to the right? To the left. So whenever we shift the decimal towards the left, we simply add the power by the number of places. So since we have shifted it by 4 places towards the left, we'll do 10 raised to minus 11 plus 4. So what is minus 11 plus 4? It is nothing but minus 7. So we get the answer as 4.002 into 10 raised to minus 7. Newton is the unit. Don't forget to write the unit, right? So with this, the numerical or the word problem is not yet done. You have to write the final statement, which is very, very important. So what is the gravitational force between them? The gravitational force between Mahendra and Virat is 4.002 into 10 raised to minus 7 Newton. So what did we understand? In order to solve a numerical, we should know how to crack the given data. Once we crack the given data by using the symbols, we should select the formula. And we have also seen how to select the formula. And you write the entire numerical in 5 steps. Given, to find, formula, solution and the final statement. So this is how we solve a word problem.
And yes, please do not forget to like, share, subscribe and press the bell icon.